Hello, hello. That does seem to be working. Okay. All right. This is the first time streaming on YouTube, so I'm going to give it a couple of minutes and then we'll get going. Alrighty, well, I think we're going to go ahead and get started. All of this will be recorded, so if you're watching this after the fact, hello. But we are also live. So the plan for today is to capture a lot of the things that I've been writing about, but also kind of as an exercise for me to figure out how to explain some things that I need to write about. So I've been planning on writing more about like Nix packages and NixOS, and getting to that point, there are some things that I'm not sure how I'm going to explain, and I thought maybe just trying to explain them would help. So what we're going to do today is that on top of all the stuff that I have already kind of jotted down in my notes. So let's go ahead and start with this. We're going to be talking about Nix and NixOS. If you want to follow along, which I recommend you do, you should head on over to nixos.org and download Nix. And I'll just go ahead and paste the command. You can see it here, but you go to nixos.org. Go to nixos.org, go to download, and then you can find Nix, the package manager, and that's the one that we'll be playing with first. And the installation looks like this. So that's the command you'll use, where you just go ahead and grab Nix install. And this is just for Nix, the package manager. I know the names are a little bit confusing. So once you have that, you'll have Nix available. And so there's a couple Nix commands. You'll see Nix dash build, channel, all these things. What we're going to be doing is actually playing with some more modern versions of these commands. You'll see there's a lot of these commands. There's a whole bunch of stuff. This has all actually been sort of simplified to just be a Nix command. However, to enable that, you need to go ahead and update your configuration. So there's a special little config file that's a nix.conf, and you can find that either in etc nix.conf, or in your home directory config/nix/nix.conf. Mine, I don't have the home one, but I have the system-wide one. So you can update that nix.conf file, and I'll show you what mine looks like. In order to have access to this more modern stuff that is still marked as experimental, but we're getting very close to it being just kind of what's the standard. And it makes things a lot easier, which is why I'm introducing it this way. So all you need to add is this line, experimental features, Nix command flakes. So for example, if you were to open up home config, that's not it, right? Yeah, that's not it. /nix/nix.conf, you would just put in experimental features equals Nix command flakes to enable these two features. Okay. And so once you've got that up to date, then you can go ahead and make use of this Nix command. So you can say Nix, and it should be useful. So in order to actually use Nix stuff, we're going to go in a little bit of a weird order, because I know a lot of people like to introduce Nix as the package manager replacement for something like Homebrew, which it is, and it's super useful in that way. But it can do a lot more things, and in order to have a good understanding of how that works and how Nix actually functions, it's important to have an understanding of the Nix language itself. That's right, there's a programming language named Nix that you use to, well, build packages and do things. So what we're going to go ahead and do here is start playing around with that language, and I'll show you the syntax for it. So I'm just going to go ahead and open up my editor in this directory and create a new file. And for our sake, I'm just going to call this example.nix, okay? And so that's the file extension for a Nix file. It's .nix. And in here, I can go ahead and write a single Nix expression. That's right. Each Nix file has one expression. That's it. That's all you get. So for example, the number 42 is one expression. And then I can go ahead and use that Nix command, one of the subcommands named REPL, or actually, sorry, not REPL, caught me by surprise, eval. And eval lets us evaluate a file, and I'll tell it to evaluate example.nix. So running that command, it will look at example.nix, evaluate the actual code we have in here to a single result, right? Because it's only one expression, it ends up with one single result, and then it prints it out. That expression could be a number, it could be a string, like hello, as we see. It could be a Boolean, like true or false. Okay. We also have some other things. We have, you might be familiar with objects or dictionaries in your language. Nix has the same thing. It calls them attribute sets. So we can make an attribute set, so a set of attributes, and it works very similarly to JSON, where you have a name equals some value, and then a semicolon at the end. You notice there's no semicolon at the end of a file because it's just an expression. These semicolons are actually just used here for the attribute set syntax. If we evaluate that, we get it printed out. Perfect. We can also say lists. So we can make lists of things. So for example, I want a list of the numbers 1 and 2 and 3. You notice there's no commas. In Nix, the spaces between elements are what delimits them. So you see 1, 2, 3 in a list. Okay. So those are kind of the basic things we have going on in Nix, very similar to what you would be used to in another programming language. Or if you're not too familiar with the programming language, at least these parts kind of make sense. If you aren't too familiar with programming stuff in general, I hate to break it to you, this tutorial might not be for you. You might be able to skirt by, but I think we're about to get into some of the slightly more complex topics that I won't explain too much. Being things like let bindings, for example, is where we start being able to, instead of just having one expression, which as useful as the number 42 is, there's only so much we can do with printing it out. Instead of that, what if we want to create variables per se? Well, we can use let bindings. It follows the structure let in, say let my number equals 42. You notice it looks a little bit similar to that attribute set syntax. We have a semicolon at the end, and then the result of this is a single expression. So let these bindings within this expression, and that results to 42, right? We set my number equal to 42, and the result is my number. We can also do some arithmetic here. I want to say my number plus 1. I think for the most part, a lot of this will be intuitive. Where things start getting interesting is some of the other syntax used in Nix that differentiates it from other languages, at least beyond the single expression stuff and the functional things. So let's start looking at how Nix is a little bit different. And we're going to look at functions first. So I'm going to create a function that is going to, we'll say, greet a name. So I'll name this function greet. It's going to take one argument, because in Nix, all functions take one argument, name, and then the result of that, an expression, will be hello. And in Nix, we can interpolate variables like this. We say hello name. And we can greet stream, or actually we'll greet chat. There we go, it works. So if I evaluate this, we'll get hello chat. Cool. What if we want a function that takes 2 arguments? If you're not familiar with this, then you might not get it right away, but I think people who are familiar with the concept of currying will see, hey, what if you have a function that returns another function? That way you can supply the first one with an argument, give the second one an argument, and then inside of that closure, you can make use of both of them. So we'll see that here. I'm going to change this so that I can customize the greeting. So greeting is going to be an argument that returns a function, or I should say parameter, but you know, back and forth. So that returns this function, okay, that takes a name and then returns this expression. So I'll say greeting. So now we need to say greet with this will return a function that we then call with this value chat. Howdy, chat. So now that we've got functions, what can we do with them? Well, we can start getting a little bit more advanced. How about we start interacting with attribute sets in functions? So let's say I have some function that, let's see, some function that I want to return a like object from or attribute set from that is some special format. Let's say like make secret or something like that, just totally arbitrary. And I'm yeah, that works. Okay, and so we're going to take some secret value and return an attribute set, and that attribute set is going to have some stuff. Maybe it's just like my super secret value equals secret, because this is just for demonstration purposes. Okay, so that secret we can just supply as like ABCD. Just like before, we're just returning a different kind of value. What if I wanted to supply, instead of just one value, maybe I want to supply multiple, but I don't want to curry this? Well, we can supply an attribute set, of course. Okay, so this attribute set gets passed to the function. Return just like before. And here's where things start to get a little more interesting. This attribute set is being used in our function, and Nix has built-in support for pulling out values of attribute sets when they're used as arguments. So if I want key and value from this, I could, you know, make a function with 2 arguments, or well, 2 functions with an argument each, and pass them a key and a value. Or I can provide an attribute set and use it like this, or maybe we you know, do something with them. For convenience, I can actually destructure this right here in the argument itself. Instead of giving the argument a name, I can rip out just the attributes on it that I want. So I can take key and value, whoops, key comma value. And then I can, in here, say, for example, value. Hey, Daraj, thanks for joining. Let me know if you have any questions while we're going through stuff. Happy to try and answer while I'm here. So we can pull out individual attributes from that attribute set. Interestingly, we can also specify just the attributes we want from an attribute set. You'll notice when I try to evaluate this, it'll error out saying, I called a function with extra stuff. That's because in here, I only specified a value attribute being named in this attribute set, but I provided more than just the value attribute. So this is great for actually restricting like data that you pass to a function, but sometimes you want to explicitly allow more things to be passed that you don't care about. And you can do that in Nix with the ... here, saying, look, I want the value attribute, and this attribute set can have other things, but I don't need them. I'm not going to use them. And so if we run just the same exact code here, it succeeds, and we pull out just the part that we actually want. Going back to actually using that value, though, the key that we have, in attribute sets, we can dynamically set the attribute name as well. And you can do this with the same syntax we used for string interpolation. So you can say this $curly's key, and that will set the attribute name just like writing it manually would. If you need, you can also use quotes around an attribute name if you need to do some more dynamic like generation. For example, like user key this. If you, for whatever reason, you wanted to name the attribute that, you could, and you can use quotes to do that, because some of these characters might not be allowed. And then finally, there is a shorthand for when you need to do something like this, because that's a lot to write. And so instead, we can just say inherit. So we have the same exact result, and it works great. And here's where we start getting to actually needing like facilities for things, right? We have most of the basics at this point. And when you want to actually like do something new, at this point you're like, well, now I'm gonna have to write a helper for map and a helper for filter, a helper for all these things. And that's where we start talking about Nix packages. Because it's not just a repository of, well, packages. There's also a library included. And in order to learn how to use this, we need to learn how to import other Nix files. And so let's go ahead and do this. I'm going to go make a new file. So let's say other file.nix. In here, I'm going to make this an attribute set that has like a function. Let's just do that greet function again. Name. Okay. And in our example here, I'm going to import that other file. And the way that we do that is I'm going to do it in our let-in, so I can assign it to a name here. So let's say my library is importing other file.nix. And let's start by just returning my library. Oh, forgot a semicolon. Cool. So we see we have an attribute set where greet is some lambda function, right? It's a function. If I go look at greet, there it is. That's what we expect. It's a function. So that means I have now imported this file, and it's an attribute set full of functions, for example, that I can use. And so I can say my library, and if I want to get at something in an attribute set, we use the dot operator. So I can say dot greet, and I can say chat. It works just like before. The difference is we've moved our code to another file and then pulled it back in. We can do a similar thing with Nix packages. So here's what I'm going to do. I'm going to say let packages equal, we need to import Nix packages, right? So just like we did our file, we're going to say import. The difference here is we don't have a path to Nix packages, right? It's up on GitHub. I could download it and then specify that in a local directory. But there is some stuff in your environment that actually knows about a local checkout of Nix packages because, well, Nix sets that up when you install it. And that's what these channel things are. I'm using flakes and stuff, so I don't have that, but let's see. Nix registry, for example. Ooh, boy, that is a big log. Suffice to say that there is this thing called Nix path. That gives you access to things like Nix packages. Think of it like directories that have a Nix file in them that you can pull in without knowing the actual path of it because it's specified in your environment. We don't typically do this in like actual use of Nix because it wouldn't be very reproducible, but when you're learning, it can be a great little thing to just kind of hit the ground running. And so this special syntax we're going to use tells Nix to look at this path, these directories, and refer to the one with this name. A little bit like C includes almost. So it's a less than greater than, and inside of there, I can give the name. So we're going to import Nix packages. Okay. And let's see what this is. Actually, I'm just going to print it out here. So importing Nix packages instead of an attribute set like our file was, is giving us a function. And this is correct because the actual entry point for Nix packages, let's see here. This default Nix, which is what Nix will import if you specify a directory instead of a file, this gives us a function. Okay, so we need to call that function, and Nix package is expected to be called with an attribute set. This lets you provide some configuration settings for the actual library and packages and stuff. We're going to give it an empty attribute set saying, you know what, just set yourself up. Use the defaults, it's cool. And if we evaluate this, let's see. Interesting, I didn't expect this part to break. Fascinating. Well, let's see if I can track this down. Well, that's a little bit rough. Let's try Nix build here and see if that'll work. It might be because we're trying to just return the entirety of Nix packages, and it's so large that it's been designed in such a way that if you try and do that, then it throws an error. So let's just do packages.lib, which is actually what we're after. Give me 1 sec, I'm gonna grab some water. Okay, so this lib thing is what we're after. And it, as you can see, contains a bunch of stuff, like a whole bunch of stuff. In fact, the best way to explore this isn't in this output. It's going to be opening up the Nix REPL. So the Nix REPL, much like any other language's REPL, lets you put in some expression and see the output. So we can do the same stuff we were doing in our file, but in here. Some of the syntax is a little different. You don't need to use let in. You can just say x equals 42, for example, without a semicolon. This is REPL specific syntax, but it's helpful for just checking some stuff. For example, we can do the same import Nix packages that we did. I am going to just do the same exact code here. So we'll say packages equals import Nix packages. And then packages.lib. I'm going to put a dot and then press tab, and we'll get a whole bunch of things here that we can actually look through. So there's a whole lot of helpers for like a bunch of different cases. One thing I didn't mention is that Nix does have some built-ins, literally built-ins dot. And so things like map and add and filter and stuff like that. Or maybe filter. Actually, I don't know if that's in here. It is. Okay. But the rest will be found on the Nix packages library. That's where we'll like get a bunch of extra helpers. So we know how to do like basic expressions with Nix. We know how to create variables and functions, and we know how to import other files, including how to import Nix packages. And would you believe it, that's actually enough information to be able to build our own package. So what I'm going to do here is create our very first package. And I'm not going to do it necessarily the like right way first. We'll do that in a minute. But we're going to do the simplest possible way with Nix, because there is a built-in function, say built-ins. Let's see here. Oh, actually, I wanted built-ins dot derivation. So derivation is a built-in function, and that is going to need a couple of arguments here. If I try and call it like this, see we have an error. So let's start filling in arguments. Say my derivation is the name. We also need a builder. So our builder is going to be, let's say bin/sh. That's the program we're going to execute to actually make our package. And we need a system. So system, I'm going to say x86, 64 Linux. And these systems you can find going to Nix packages again. Packages lib platforms lists, well, a whole bunch of things. Let's see, if I use built-ins, one of the helper functions from the built-in functions will get all of the names from an attribute set, all of the attribute names. And we're going to use that on platforms here. So you can see there's a whole bunch. In our case, we're going to use x86 64 Linux because that's what I'm on, so I'll be able to build this package. And then we're going to also specify some args that are passed to the builder. And this will let us do something like give sh a command to run. So for example, echo hello to some special thing called out. Ooh. So calling eval on this results in like a big attribute set being returned. In fact, this is the result of our derivation. So if I say, let's see, Nix instantiate, which lets us create derivations. I think, if I remember correctly, I can just give it the file, example.nix. Perfect. So to create our package, there's a few steps. First, we create a derivation. Ooh, you can think of this as the package, but it's actually like one step before realizing this and actually producing the package. So think of it more as just, here's like the settings for creating my package. The next thing that happens is we make a derivation. So the actual result of this, Nix goes ahead and produces a derivation file, which looks like this. So you'll notice it's all the same information we gave to our derivation function, just formatted differently. That's it. And it also has one extra bit of information, out. So packages need a place to put their built files, and they get supplied automatically with something called out, which is their place to put them. Out is provided as a variable in the environment when that package is building, and it refers to a specific folder. And in the case of our derivation, it's this path exactly. It'll always be in /nix/store, but the big gobbledygook numbers are a hash based on the inputs of your derivation, so that'll be unique. And then the name is what follows it. All of your other information is still carried through in here. Once we have a derivation, we can go ahead and realize it. Let me double check this. Nix. Which command was it? Nope. I thought it was like Nix store realize. Let me just make sure I'm not missing here. Yeah, -r. So then we can take that derivation and ask Nix to actually build it. And then we get the actual build output. And in our case, that is going to be a file because we wrote to that destination. So I can cat, and we'll get hello. So that's our very first builder. Very, very first. Actually just writing a little bit of text. However, using the derivation function directly is very tedious and requires you to basically rebuild everything. Because this builder, for example, the only thing you'll be able to use is /bin/sh. Anything else, and you're just going to need to have it in the directory that you're in. So unfortunately, not too much you can do with the actual raw derivation function without a lot of work. However, the beauty of Nix packages is that all of that work has already been done. So we're going to go ahead and use Nix packages stuff to build this. Let's start by, instead of bin.sh, let's say our builder is going to be packages.bash, which is a package from Nix packages. And instead of doing Nix instantiate and Nix store realize, I'm just going to say Nix build the file example.nix. Oh, permission denied. That may not work. We'll see. Nope. All right. Well, that stinks. Not too big of a deal. I suppose what we can do instead is jump directly to actually using some of the tooling in Nix packages to actually build the derivation, because there's wrappers around this derivation function, particularly the standard environment. Let's take a look at one of the simpler ones though. There's a helper that you can use in place of built-in's derivation, which packages.run command. You give it a name, my derivation, and I can't remember if let's check the signature of this. So I can open the Nix REPL. Instead of doing import packages, I can just do L here, and then tell it what to load. That's what the L stands for. It'll import Nix packages, and then everything will be available here. So I can say like packages dot or lib dot. In our case, I want run command, right? And I want to see in my editor that code so that I can see how to call it. Okay, cool. So it is going to look like this. I didn't show you multi-line strings yet, but this is multi-line strings. It's just 2 single quotes. And then in here, we can do the same thing as before of echo hello to out. Now, I didn't use Nix instantiate and Nix store, so we don't have like a path printed out here. But that's okay because Nix build writes out a result file, or more specifically, it creates a symlink to the actual built thing, and the file in our local directory result just points to it. So I can cat results. So it gets a little bit easier. And depending on what you're packaging, there's probably already facilities in Nix packages to do that for you. So if it's a standard C++ or C application, you can use the standard environment and say make derivation, and it'll take care of just about everything. And there's builders for Python and Go and Rust, and I'm sure a few more things like JavaScript and so on. And so this really does just break down to doing the same thing that we did with the derivation name, my derivation, and so on. And so this is how packages are constructed in Nix packages. Or more specifically, packages in Nix packages mostly use the stdn.makeDerivation function, which is a more fully formed wrapper around the derivation built in. So this will do the same thing. The difference is this orchestrates a lot more stuff. There's this concept of phases, right? Phases of a build where first you might need to run some patches on some code, then you might need to run a configure step, then you need to build, then you install it, then you like test to make sure it worked, then you maybe do a little bit of fix up. There's a bunch of these phases, and they can be found in the Nix packages manual, and that's all part of make derivation, this special helper that's written in Nix packages. It's not a built-in. So for our case, we can go ahead and say like, let's say build phase is echo hello to out. Oh, see, I got an extra semicolon. And importantly, make derivation needs a source of some kind. So we'll just give it the current directory. And let's actually swap this out. Instead of build phase, we'll use install phase. As I mentioned, this like orchestrates a lot of stuff. And so when an error is spit out here, it's because it's like trying to build a certain kind of project, and we don't need any of that. So anyway, we end up with the same result here. There we are. And so the reason that you would not use derivation directly is because it requires a lot of work to configure all your things. You have to do every part of the build yourself, every build step along the way. You have to include all of your dependencies as well, which you still have to do that normally, but it's more tedious there because you have to set up your path and things like that. Make derivation or any of the other helpers found in Nix packages wrap the derivation function to do all of that busy work for you. And so typically you're only going to reach for make derivation, or actually not even just typically, all of the time you're going to reach for stdnv make derivation, or you reach for one of the more trivial builders, one of the more simple ones, like run commands, right? Which we looked at just a moment ago, which was a very simple, like, it's a bash script. Execute this and you'll get the output. So that's how we can create packages in Nix. All right. I think the last thing that we'll touch on here, it's a bit of a shorter stream, but I think the last thing we'll touch on is going to be the module system, because that puts us in a cool position to look at NixOS next time. So over in the REPL here, I just have Nix packages loaded. Nix packages, the library, comes with some cool stuff, some cool helpers, some of which you've seen. But it also comes with this awesome helper for, what's a good way to describe this? You give this thing these, gosh, it really is a tough thing to describe, isn't it? It's a generic way to provide configuration that all gets type checked and collapsed into, well, a resulting configuration. So what does that mean? Let's actually use it here. We'll see. I'm going to go ahead and create a module. Call it module A. Okay. Module A is just going to be an attribute set that has one thing. It's options dot. We didn't talk about dot. This just means the same as something with an attribute set that has a property. So options.x, the same as options equals an attribute set with an x property that is something. Just really just shorthand. We'll say options.a.enable. And then we're going to set this equal to lib.makeEnableOption. We'll look at this in just a second. And then I'm going to use lib.evalModules. And I'm going to give it our module as one of many that we could give it. And we'll take a look at this result. We see result has this thing called options, which looks similar to our options, right? We see, oh, hey, there's A and enable. Okay, well, that's interesting, but all we see that it did was it took our module thing and gave it back to us. So let's go one step further, and instead of module A, let's do a module B. It's the same exact thing, but the letter is different. And I'll provide both of them. You'll notice those have been combined. And we can get at each one's settings. So all of these modules end up being collapsed Now that's cool, but we can merge attribute sets normally, so that's not wildly impressive. Where it starts getting interesting is that these modules take three things. They take potentially three things. They take options, they take config, and they take imports. Imports lets you specify a list of other modules, so that we've kind of already seen. Options, we just saw, let you, well, specify some name. That's about it. All right, we have a.enable so far. Config is where things start to get unique, where I can say my config is an attribute set, and then we can, using those option names, set some information that will be checked against the type of those options. So for example, if I say a.enable equals true, and I come here, I have both a and b, and we say result.config.a.enable, you'll see that it's true. If I try and use this module without the option a being available, you'll see a does not exist. And this isn't like a language error, this is a type error in the module system. It's super cool. But wait, it gets better. I'm going to make a utility module here that all its job is to have an option, gives us an output thing. I'm going to make a custom option type. The type is going to be lib.types.string. Okay. All right, we don't need to worry too much about that just yet. In here, I can specify module A, B, and C, and we'll get the same stuff as before, okay? No changes just yet. Now, the difference that I'm going to make is module A has the option a.enable. Module C has the option output. Module B, instead of being an attribute set, is going to be a function that takes the config and some other stuff and can give us back, well, the like module definition here. So it's going to get the config that you've set, the merge config, and it can set its own local config to merge stuff. And in there I can say output equals something. See, output equals something. Interesting, so we're merging some stuff. Now, what if this configuration was only enabled when A was turned on? Well, we can do that. Output is used but not defined. Interesting. Let's see here. I may have... Oh, I don't see a problem there. Well, you'll have to take my word for it. Next time I'll have to have a better example here. As it will be a better example because we'll be going through actual NixOS stuff, which uses the module system, as opposed to trying to do all this manually. There's a helper in Nix packages that will call the lib .eval modules for us with all the stuff it needs to. But that's the interesting stuff about the module system, is you get the ability to take compartmentalized configuration with these options in config and merge them all together, and they can all lazily depend on each other. So one module might be able to change its configuration based on options that you've set in your config, which is super cool. And this is all contained within the Nix packages library. So just in lib. And you can use all this stuff on its own outside of Nix packages. The big reason for this stream specifically is to like show there's a lot of stuff that just Nix can do before you even start touching like Nix packages, the actual like, well, when you think package repository. And then once you start using all of those helpers, then you get superpowers. And so that's super cool. So I think what we're going to do is probably stop around here. And next time we'll be looking at some like NixOS configuration, or more specifically, NixOS configuration in the terms of Nix Flakes. Because I think from here is a good like jumping off point to see like, okay, I know how to write some of these things, but I'm not going to have just like a random default.nix lying around or example.nix or whatever. Is there a structured way to actually do all this? And the answer is yes. And that'll be done with Flakes. So next time we'll want to take a look at that. Alrighty. I know it was much shorter than maybe I expected even. But about an hour, as my throat is still kind of recovering from last week. Awesome. Well, I hope it was helpful. And I hope that, if anything, you're like a little bit interested in Nix, because there's some cool stuff. I recommend checking out the most recent site from, let's see, Determinate Systems. Let me get a link for that in chat. As I think 0 to Nix was so far kind of the best resource, aside from Nix Pills, which goes a little more in depth of kind of the stuff that we covered today, really. So both of those are worthy of being bookmarked, I think. So with that, I'll hang out for another minute or two if anybody has any questions. But I think that's where we stop today. Alrighty then. Well, hopefully that was a decently successful first YouTube stream. And if you managed to watch through this whole thing on the VOD, then I applaud you, because I know it was a little rough stopping here and there, still recovering from throat stuff from the last week. So hopefully that improves, and next time I can give you a little bit of a longer stream, or at the very least we can cover Flakes in NixOS. So hope y'all are doing well. I will catch you later.